Namaste to all my dear students. How are you? Again, I am giving you very interesting video about hydrogen sulphide. That is very important for knowledge as well as examination view of point. So this one is what you see, hydrogen sulphide. Compound of sulfur, we can say sulphide, that is also known as sulfurate hydrogen. That is also very important. So MF is hydrogen sulphide. Molecular weight is 2 plus 32. How much? 34. Is vapor density is equal to what is it? 34 by 2. How much? 17. Yes. So lab preparation of what you see, preparation of hydrogen sulphide. Yes. So when ferrous sulphide is reacted with dilute sulfuric acid, we get hydrogen sulphide gas, which is collected in by upward displacement of air. Why? Because it is heavier than air. Yes. So ferrous sulphide, that is solid black color, and when treated with sulfuric acids, what we have? Ferrous sulphate plus H2S gas, that is the gas H2S gas. So generally in lab, so we have to prepare, manufacture the what you see H2S gas in larger scale. So what we used for, so what we used, keep, name of the chemist, Kip's apparatus is used to prepare large amount of hydrogen sulphide in lab. Yes. So sometimes question is arise. So why hydrogen sulphide is not dried with Kong sulfuric acid? Generally asked in the examination. Question is like this: why hydrogen sulphide gas is not dried with Kong sulfuric acid? So see the what you see answer of this question. So at first look at over here, H2S plus Kong sulfuric acid. So what you get? H2O plus sulfur plus what you see, sulfur dioxide gas. Yes. So in this case, what the role of H2S? Plus 6. In this case, plus 4. Yes. So what the role of this H2S is reductant. What the function of this H2SO4? Minus 2 to what is 0. Yes, minus 2 to 0. So that is what is the oxidant. Yes, that sulphide is what is the sulphide oxidation. Yes, so Kong sulfuric acid to sulfur dioxide. So that is reduction. Yes, you know. So I think you have clear why Kong sulfuric acid is not used for drying the what is the H2S gas. So what the answer of these questions we have already seen over here. So here hydrogen sulfide gas reduces Kong sulfuric acid into sulfur dioxide gas, and Kong sulfuric acid what is it oxidizes hydrogen sulfide to sulfur. It means redox reaction takes place and we can not dry H2S with Kong sulfuric acid. Yes, Kong sulfuric acid. I think we have clear. So generally asked in exam is very important for you. So now important chemical properties of H2S. It's very important. So first one is as weak diprotic, or we can say simply weak what is it diprotic, or so weak means what is it ionization is very low, so that is weak acid. So when we talk about H2S after ionization, what you get 2H plus sulphide. Yes, so how many hydrogen replaceable? It's 2 replaceable hydrogen. Here also 2 replaceable hydrogen. Yes. So when how many 2H over here? So when that is treated with sodium hydroxide first molecule, so what you get H2S, we get NaHS plus what you see H2O. What the name of this compound? Sodium hydrogen sulphide. Yes, 1H over there. Now react with another molecule of sodium hydroxide, that is the base, that is the acid. Yes, another molecule react with this sodium hydrogen sulphide. So what you get? Na2S plus what we see sodium, that sodium sulphide. Yes. So what we see over here? So two type of salt is formed. First one is sodium hydrogen sulphide and next one is sodium sulphide. In this case any H over here? I think no. Why? Because both H is substituted by sodium metals. What it shows? It has 2 replaceable hydrogen. It is dibrotic, dibasic, or we can say it has two replaceable hydrogen. Yes, I think we are clear. We sometimes ask you how can you show H2S gas is weak diprotic gases. So at first we have to ionize it. So what we have 2H plus and sulphide. Now this treated with first molecules, what we have? Sodium minus 1 H is substituted, another base substituted, another H, and what we have? Sodium sulphide plus water. So I think you are clear. Yes. First one is weak acid. Next one is reducing properties. Reducing properties, or we can say reductant. Very important. Sulfur dioxide and H2S both are important. So first one is with acidified solution of potassium permanganate. So formula is like this: KMnO4, potassium permanganate. Yes. So generally ask you in what happens. It's very, very important. So when language like this, when gas is passed through acidified solution of KMnO4, potassium permanganate, we get colorless manganese sulfate by reduction process. Like see the what's the reaction over here. So what we see, KMnO4 acidified with dilute sulfuric acid, and when pass H2S gas through this solution, so what you get? K2SO4 MnSO4 plus H2O plus sulfur. Eradicated downward means what you see? Deposition, solid formations. What? Mn has plus 7, that is potassium permanganate. Its color is what you see, pink. So what the function of this H2S? Process is reduction. What you get? Plus 2 colorless. Yes. So what is it? Plus 7. So what the function of this H2S? Reduces plus 7 to what is it? Plus 2. Now question is how can you get by partial equation? That is the what you see, net reaction balance, net reaction only we can say. So at first KMnO4 dilute sulfuric acid reaction, what to get? K2SO4 MnSO4 plus H2O plus nascent oxygen. Now this nascent oxygen H2S, oxidizing agent, oxidation. So what to get? H2O plus sulfur. Yes, that is what is the balance. What is the partial equation? You know. Now the balancing, after balancing, what we have? after balancing we get 2KMnO4 potassium permanganate, 3 sulfuric acid plus 5 H2S in left hand side. Right side is potassium sulfate plus 2 manganese sulfate plus 8 H2O plus what you see 5 yes. So after balancing what we have 2KMnO4, 3 dilute sulfuric acid, 2 MnSO4, 3 H2O, 5O. That is 5O. So we have to multiply 5 by to cancel this nascent one. So after adding and subtracting what we get? This one. 2KMnO4, 3 dilute sulfuric acid, 5 H2S in right hand side, 2 MnO4, 8 H2O plus what you see 5 sulfur. Yes. So we have to balance all this by partial method. I have already learned you in partial equation. Yes, we have to see all these. B. With acidified, all are important. That is also important. Acidified potassium dichromate solution. So language like this, when H2S gas is passed through acidified solution of potassium dichromate, we get green colored chromium sulfate by reduction process. Look at over here, reaction is like this. Potassium, that is potassium dichromate acidified with dilute sulfuric acid, hydrogen sulfide gas. So what we have? Potassium sulfate, chromium sulfate, H2O plus sulfur. So what you see? Plus 3 oxidation number and its color is green. That is potassium dichromate, its color is orange, yellow. Chromium has plus 6. So what you say again? Process reductions. What you get? This H2S reduces what you see? Potassium dichromate into green colored chromium sulfate. That is chromium sulfate. Yes. Now how we can do? So what you see? You have to see its partial equation. So what we have? Potassium dichromate plus dilute sulfuric acid at first reactant. What we get? Potassium sulfate, chromium sulfate plus what you see? H2O plus nascent oxygen. Yes, this nascent oxygen oxidized hydrogen sulfide to H2O plus sulfur. Yes, so after balancing, what we have? After balancing, we have 4H2SO4 dilute, and what we see 3H2S. After balancing, what we see? Just for K2SO4 and chromium sulfate, let's see 4H2O, and how many O? 3O, I think. 3O. In this case 1O, so we have to multiply by 3. So what we have? K2 Cr2 7, 4 dilute sulfuric acid H2 multiplied by 3. So what to get? I had 3 molecule of H2S. Right hand side is K2SO4 chromium sulfate plus 4 and what is it? 3. So how much? 7H2O plus 3 sulfur. What we have? Three. Yes, yes, already balance. Yes, C with acidified solution of ferric chloride. So when H2S gas is passed through acidified solution of ferric chloride, we get light green in ferrous chloride compound by reduction process. Like what we have. So ferric chlorides. Let's see, ferric chloride plus H2S dilute HCl. So what we get? Ferrous chloride plus 2HCl plus sulfur. So in this case plus 3, in this case plus 2. Its color is reddish brown. In this case light is also H2S reduces ferric chloride to ferrous chloride. Yes, that is ferric chloride, that is ferrous chloride. It is reducing properties. Next one is reaction with halogen. X2 maybe chlorine, maybe bromine, maybe iodine. Yes. So when H2S is chlorine, what we have? HCl plus. So what is what the function of this H2S is 0 to what is -1. Yes. Likewise H2S plus Br2 hydrogen bromide, that is hydrogen bromide. So what the function of this one? 0 to what is it? -1. So what do you see? Reducing properties. Then talk about the H2S. So what the role of H2S over here? Reductant, and that is oxidant. Yes. 2 Br, 1 Br, so to multiply by 2, 2H, 1H, Br2 balance. Yes. Likewise, chlorine, 2 chlorine. Next one is with conc nitric acid. So what you get? Treated with conc nitric acid. So what we have? H2. What's the net product? It H2O plus NO2 plus sulfur. So after balancing, what we have? 2HNO3, 2NO2 already balanced, 2H2. Yes. So that is H2S hydrogen, that is the conc nitric acid. So what we see? So in this case, H2S is reductant, that is oxidant, -2, 0, that is +5 to +4. Yes, redox reaction you can say. Next, very important, what is 6? Precipitation reaction, that is asked in examination. Precipitation, analytical use of H2S in lab, very important. Generally asked 5 marks. So analytical use of H2S in what is it? Lab. First one is what is it? Second group cation. Second group second. Group second cations. Cations means positive charge in acidic medium. So what do you say? So some metals give sulphide with H2S gas, acidic medium, because they have lower solubility product value. Yes, always as a note, always keep in mind for precipitation. Always keep in mind, for precipitation, formation, ionic product of the soluble electrolyte must exceeds its solubility product. Always keep in mind, ionic product of the soluble electrolyte must exceed its solubility product. Always we have to keep in mind. Yes. So example are like this. For example, copper, Ag, lead, arsenic, bismuth, what is it, tin, and what is the antimony. This is antimony. That is antimony. So for example, what we have, copper sulphate plus what is the H2S in presence of dilute HCl, must be in acidic condition. So what we have, copper sulphide plus sulfuric acid, that is the black PPT. PPT means what is the precipitation. Likewise, when you talk lead sulphate plus H2S, same dilute HCl, what we have, lead sulphide plus sulfuric acid, that is also black PPT. Likewise, mercuric sulphate plus H2S, so what to get, black PPT plus what you see, sulfuric acid. Some more example is like this. Antimony, that is antimony chloride, and H2S, hydrogen sulfide, in presence of dilute HCl. So what we have, Sb2S3, that is antimony sulfide. Yes, antimony sulfide plus side product is what you see, HCl. How many? Chlorine 3. So what you see, 3 HCl. How many hydrogen? 2. So not balance, I think. So 2 Sb balancing 3 H2S. So what we get, 6 HCl. So what the color? Orange PPT. Likewise, HCl, that is stannous chloride. When H2S, presence of dilute HCl in acidic medium, what we have, plus what we see, HCl, that is tin sulphide. Tin sulphide, yes. So chocolate PPT, brown color you can say, chocolate, reddish brown, better to say, reddish brown PPT. Yes, balancing is like this. So what you see, H2S, SBS, 2HCl. Yes. So that is what you see in acidic medium. Yes. So these metals give PPT in acidic medium. Next one is B. What you see? Group third B. Third B cations generally give PPT in alkaline medium because what you see, because sulphide of these metals have relatively high value of solubility product value. For example, zinc sulphate. So always what we have to use, excess of ammonium chloride and ammonium hydroxide, then we have to pass H2S. Solution must be alkaline. So what you get? Zinc sulphide. What type of PPT? White PPT. Yes. Likewise, nickel sulphate plus ammonium hydroxide plus H2S alkaline mediums. What we have? Nickel sulphide, black PPT. Nickel sulphide. Next one is cobalt sulphate plus what you see, ammonium chloride, ammonium hydroxide. Solution must be alkaline. Yes. So what you see, cobalt sulphide is what you see, black PPT. Last one is manganese sulphate plus ammonium chloride, ammonium hydroxide, H2S. Condition must be alkaline. So what we have? Manganese sulphide. Yes, PPT plus carbon like meat colored PPT. Yes, so very important questions. So what are the right question is like this. Write analytical application or use H2S in labs. In labs, you have to write both in acidic medium and alkaline medium. Generally asked in 5 marks. It's very, very important. Sometimes ask you question 1, suppose question 2, why zinc do not give precipitate H2S medium. So, answer is zinc sulphide dissolves in dilute HCl. Dilute HCl, so it does not give PPT. In acidic medium, you can say so. This is the what is simple answer. Sometimes you can say zinc sulphide has higher solubility product value. So, in acidic medium, it does not any product exceed to its solubility product, so it does not give. So, you always give PPT in what you see alkaline condition, because in alkaline condition what we have is ionic products exceed to its solubility product. So, always we have to know the principle. For PPT formation, always ionic product must exceed to its what is solubility product. Yes. So, that is simple answer. Yes. Question 3, write important reducing properties of H2S gas in the lab. I have already told you with acidified source of K1,4, potassium dichromate and ferric chloride. Yes. So, these are the main reducing properties. Now, uses H2S. It is used for identification, separation and isolation of cations present in inorganic. Yes, first one. Second one is it is used as a strong reducing agent. Third one is it is used as an analytical reagent in labs. Very, these are the main uses of what you see H2S gas. Yes. So, I thank you for saying or visiting this what you see interesting what you see video about H2S gas. and I think also you have subscribed it and also convey your friends for learning what is the channel for learning. So good, have a nice day. Good, be healthy, be happy, be bona fide in chemistry like Sheila Khan sir. Rest is okay.